My name is Dušan Mastorović from Typhoon Hill. Let me first explain the setup that we can see here on the table. So on the left-hand side we have a multi-purpose industrial controller, which in this case we use for active filter application, Hill 400, and picoscope, USB-based oscilloscope. This controller, or this control algorithm used for this active filter application, is developed by the help of Hill 400 emulator. So let's first focus on the plant model used in this application. So as I mentioned before, we are using active filter application, especially for train application, railroad application. In this case, we have a model of the grid, like 3 voltage sources plus RL, then contactor, then we have a passive filter to filter the switching harmonics, and then inverter with DC link. Okay. In this window, we are looking at the control panel for this multi-purpose controller. Here we can set different parameters. We have signal readings from the controller, and we can basically turn on and off harmonic compensation used by this filter. Also, another important point in the model, the load is modeled by means of current sources connected in parallel with grid. Okay, the emulation is started, so our virtual plant is running now in real time on Hill 400 emulator. Okay, and let's go back to the control. Okay, then also let's take a look at the signals that we are going to see in this presentation. So the red trace is a grid voltage, then the yellow one is the load voltage. Let me just show this. This is basically the load voltage, loading the grid. Okay. Then the blue trace is inverter voltage. At this moment, the filter is turned off, so we have zero voltage, zero current going through the inverter. And the green one is a total grid current. Basically, the current that comes directly to grid. In this case, it's the same as the load voltage because filter is turned off for the moment. Okay, let's turn on the filter. First, we are enabling active filter. For now, it's not doing any harmonic compensation, but it started switching, and we can see that clearly in the current. So we have some current now through the inverter, but more or less the current going to the grid is quite similar basically to the load current you see. Also, on this control panel, we can check the harmonic content of the current going to the grid. Like this. Okay? Now I'm about to start the harmonic suppression function of this filter. Okay, we can immediately see the effect of the grid current. We can now see that it looks more like a sign that we really like to achieve. Of course, there are some high frequency noise coming because the filter is suppressed only to a 15th harmonic. So, but also the switching frequency is not that well suppressed by a passive filter in front of the inverter. But as we can see, the harmonic contact, the higher harmonics have much lower amplitude than it was in the first case, and the current going to the grid is more looking like sine. It was something that we really wanted to achieve with this application.